Welcome to Pastor Victor's Academy. Embark on a journey through the world of engineering mathematics and electrical engineering with our educational tutorials designed specifically for engineering students. Whether you're mastering calculus, solving complex circuit problems, or exploring power systems, Pastor Victor's Academy is your ultimate learning companion. Join us as we break down complex concepts into clear, easy-to-understand lessons, helping you build the foundational knowledge and skills needed to excel in engineering mathematics and electrical engineering courses. Subscribe now to kickstart your learning journey and gain the confidence to tackle engineering challenges head-on. Let's unlock the world of mathematics and electrical engineering together, one lesson at a time.
Good day. Welcome to Pastor Victor's Academy. I'm very happy you are watching this video. In my previous videos, we looked at energy, work, heat, and thermodynamic cycles, and I've given you the energy balance equation for a closed system and also the equation for a thermodynamic cycle. In this video, we'll be using the question on the board as an example, so do well to pay attention as we continue. The question says a closed system with internal energy of 90 joules and kinetic energy of 35 joules moves to a new state after doing 22 joules of work while receiving 56 joules of heat. Now the A part says if 60 joules of work is done on the system to return to its initial state, how much heat is received or lost by the system. Now the B part says if 65 joules of work done on the system brings it to state 3, where the internal energy is the same as that of state 2, and its kinetic energy increases to 40 joules, and heat lost in this process is 35 joules, determine the internal energy and kinetic energy at state 2. Assume there is no change in the potential energy of the system for all processes. So here we have a system having an internal energy of 90 joules and kinetic energy of 35 joules. It moves to a new state, of course, we call it state 2, after doing 22 joules of work while receiving 56 joules of heat. We have our A part requesting, it says, if 60 joules of work is done on the system to return it to its initial state, how much heat is received or lost by the system? So we can use the energy balance equation for a closed system to solve this problem. We can also use the equation for a thermodynamic cycle to solve the problem. Now, for part B, it says, if 65 joules of work done on the system brings it to state 3, so at this point, the system moves from state 1 to state 2. From that state 2, if 65 joules of work done on the system brings it to state 3, where the internal energy is the same as that of state 2, and its kinetic energy increases to 40 joules. So the internal energy is constant from state 2 to state 3, while kinetic energy increases to 40 joules. And it says heat lost in the process is 35 joules. We are asked to determine the internal energy and kinetic energy at state 2 with the assumption that the potential energy of the system does not change for all processes. So there's something I want you to do. Just pause the video. Try solving the problem by yourself. Show your steps and write down your answers. Then continue watching the video to know if your steps and answers are correct. Welcome back. I want to believe you tried solving the problem by yourself. So let's do it together. For the energy balance equation, we have that Q minus W is equal to change in U plus change in KE plus change in PE. But for a thermodynamic cycle, we said work cycle is equal to heat cycle. Now, for the first part, we are having U1 is equal to 90 joules. KE1 is equal to 35 joules. Work 1, 2. Now, we didn't say 1 or 2 because work is a process, likewise heat. So it's a process between two states. So work 1, 2, that's the work between state 1 and state 2, is equal to 22 joules. Heat 1, 2 is equal to 56 joules. U2 is equal to question mark, that's unknown. Then KE2 is equal to question mark, that's unknown. Then U3 is equal to U1 because we were told the system returned to its initial state. Then KE3 is equal to KE1. Then work 2, 3, that's work done between state 2 and state 3 is equal to minus 60 joules. In this case, we're having a positive value. In this case, we're having a negative value. Why? This is work done by the system, but this is work done on the system. So in the energy balance equation, Q is referring to heat received by the system, whereas W is talking about work done by the system. So this will be positive if work is done by the system and negative if work is done on the system. Whereas this will be positive if heat is received by the system and negative if heat is lost by the system. So Q12 is positive while heat was received by the system. Now for part B, we have U2 is equal to U3 because we were told that the internal energy is the same as that of state 2, that is constant from state 2 to state 3. Then we're having KE2 question mark, that's unknown. We don't know the value and that's what we are looking for. We are looking for KE2 and we are looking for U2. Then work 2, 3 is equal to minus 65 joules while work is done on the system. Then U3 is equal to question mark. We don't know what it is. So when we get U2, automatically we've gotten U3. Or when we get U3, automatically we've gotten U2. Then KE3 is equal to 40 joules. Then Q23 is equal to minus 35 joules. Why? Heat lost in this process is 35 joules. So heat lost has a negative sign. So for part A, we're asked to determine the heat received or lost by the system to enable it to return to its initial state. And we want to call that Q23. That's the heat lost or received from state 2 to state 3. So using the energy balance equation, Q12 minus W12 is equal to U2 minus U1 plus KE2 minus KE1 plus change in PE. And remember that this guy is 0 because we were told to assume that there is no change in the potential energy of the system for all processes. So we're having Q12 56 minus W12 22. Then we're having U2, we don't know U2. Then U1 90. Then plus KE2, we don't know KE2. Minus KE1 35 joules. Then plus 0. So this becomes 56 minus 22, we'll be having 34 equal to U2 plus KE2 minus 90 minus 35. Now for the next process, we'll be having Q23 minus W23 equal to U3 minus U2 plus KE3 minus KE2 plus change in PE. This guy is still 0. So we don't know the value of Q23. Then we're having work 23 to be minus 60. U3 is equal to U1, then minus U2 plus KE3 is also equal to KE1. So we'll be having KE1 minus KE2. Now that gives us Q23 plus 60 equal to, what's U1? U1 is 90 minus U2 plus KE1 is 35 minus KE2. And that gives us Q23 plus 60 equal to minus U2 minus KE2 plus 90 plus 35. Now let's call this equation 1 and call this equation 2. So we'll be adding equation 1 and equation 2. So you'll be having U2 plus minus U2, that gives you 0. KE2 plus minus KE2, that gives you 0. Minus 90 plus 90, that gives you 0. Minus 35 plus 35, that gives you 0. So you can see that for a cyclic process, change in energy is equal to what? 0. So we're having Q23 plus 60 plus 34 is equal to 0. So that implies that Q23 is equal to minus 94 joules. Remember, we're required to get heat lost or received by the system. The energy balance equation says Q is heat received by the system. Then Q23 is the heat received by the system, which is minus 94 joules. So in other words, we can say that the system lost 94 joules of heat. So Q out is equal to 94 joules. Now let's solve this same problem using the thermodynamics cycle equation. That's work cycle equal to Q cycle. So we have Q cycle minus work cycle is equal to what? 0. So what does this mean? That Q in minus Q out minus W out minus W in is equal to 0. Here we're having in minus out, whereas here we're having out minus in. Why? We said Q cycle is positive when heat is received by the system. So the focus is on heat received by the system. But work cycle is positive when work is done by the system. So the focus here is work done by the system. So work out is subtracting work in. And here Q in is subtracting Q out. So we're having Q in minus Q out is equal to work out minus work in. So we'll come back to part A. Q12 is positive, that's 56 joules, minus Q out. Why did we pick 56 joules for this? That's heat received by the system. Work out, which is equal to 22 joules, minus work in, which is equal to 60. Now, you may be wondering why I didn't put the negative sign. For the previous method, we must insert the negative sign. The negative sign here shows that work is done on the system, but we are using it in the sense of work done by the system. So the negative sign is showing that this work was not actually done by the system, but was done on the system. But in this case, we are using it in the right sense, so there's no need for this negative sign, else your answer will be wrong. So we'll be having 56 minus Q out. That gives us minus 38. So Q out is equal to 56 plus 38, which is equal to 94. So we can say Q out is equal to 94 joules. So you can see we got the same answer using different methods. Let's look at the B part of the question. So for the B part, the only thing that changed is process 2, 3. Process 1, 2 is still the same. Now we are having Q12 minus W12 equal to U2 minus U1 plus KE2 minus KE1 plus change in PE, and this is 0. Now, what do we have? Q12 56 minus W12 22. Then U2, we don't know U2. We're having U2 minus 90 plus. We don't know KE2. KE2 minus 35. This is 0, so there's no need for it. So we're having 56 minus 22. That gives us 34, which is equal to U2 plus KE2 minus 90 minus 35. So 34 plus 90 plus 35 is equal to U2 plus KE2. 34 plus 35, that's 69. 69 plus 90, that gives us 159. Now Q23 is equal to minus 35, then minus W23 minus 65, which is equal to U3 minus U2 plus KE3 minus KE2. There's no need for changing PE. So this gives us U3. U3 is equal to U2. So U2 minus U2 plus KE3 is given as 40 joules. So we're having 40 minus. We don't know KE2, so we say KE2 minus 35 plus 65 is equal to U2 minus U2, that's 0. So we're having 40 minus KE2. Now this is the same thing as 65 minus 35, then minus 40 equal to minus KE2. Now 65 minus 35 gives us 30. 30 minus 40 gives us minus 10 equal to minus KE2. This implies that KE2 is equal to 10 joules. So we've gotten our value for KE2, which is equal to 10 joules. What do we do? Let's call this equation 1. So we'll come to equation 1 and substitute for KE2, which is equal to 10 joules, and we'll be able to get the value of what? Our U2. So that will be U2 is equal to 159 minus KE2. Here's our KE2, which is equal to 159 minus 10, which is equal to 149. So U2 is equal to 149 joules. So finally we have U2 equal to 149 joules and KE2 equal to 10 joules. So here we have our answers for part B. U2 is the internal energy at state 2. KE2 is the kinetic energy at state 2. U2 is equal to U3. So U3 is also 149 joules. Remember the assumption that there is no change in the potential energy of the system for all processes. I don't know if you got the same answers, and I don't know if your steps are the same. If your answers are wrong, at least you have this to look at. Go through the example again. But if your answers are correct, congratulations. Thank you so much for watching. Please do well to like, comment, share, and subscribe. I want my video to reach more students. God bless you for watching.